Welcome to Maths and Science series. This is Elton. Today we'll be doing momentum for grade 12. Do not forget to like, subscribe and hit the notification bell so that you can be notified when we upload new video. Yes, and also please do not forget to share the video to other people. Momentum is the product of an object's mass and its velocity. So that's the definition for momentum. It's important for you to know it. It carries 2 marks. So what does this mean when they say momentum is the product of an object's mass and its velocity? The word product means multiply or multiplication. Remember that when we sum, we add. When we divide, it is called we're getting what the quotient. Then when we subtract, that's difference. But now when they say it is the product, it means that we get momentum of an object when we multiply the object's mass and its velocity. For an example, there's a car of 750 kg. Now for you to get its momentum, you need to multiply that mass with the velocity of that car. I don't know if you understand that. So that's what this definition says: the product of an object's mass and its velocity. For you to get the momentum of an object, you need to multiply its mass, the object's mass, and the object's velocity. So if there's no velocity, we cannot get momentum, because for momentum, for us to get momentum of an object, we need to multiply that object's mass and its velocity. I hope you understand what I'm explaining here. And momentum has a formula, P equal to M times V, which is P equal to mv, where P it is the momentum measured in kg meters per second, then m it is the mass measured in kg, then v it is the velocity measured in meters per second. Now the SI units for momentum, it is the SI unit for mass multiplied by the SI unit for velocity, which is kg meters per second. Now we'll do examples which require you guys to calculate momentum. Now when an object moves, it tells us that there is a velocity of that object, and that moving object, it has mass. It means that you multiply its mass with its velocity to get the momentum. Now we'll do examples so that you can see how this thing of momentum works. So you must pay attention. And another thing, when you calculate momentum, it is very important for you to consider the direction of an object. All right, let's do the first example, then we continue with it. Suppose you are given an object or a ball of mass 2 kg, and the direction of the ball is to the right by 1.5 meters per second, its velocity. Now they say calculate the momentum of the object, or calculate the momentum. All right, the most important thing, or the first thing which you must do, just collect your data. You have velocity, which is 1.5 meters per second, and you must consider the direction. Look, it is magnitude here, and the arrow depicts what the direction. So it is to the right, which means it is positive, right? Positive 1.5 meters per second, right? Now the mass it is of 2 kg. We are heavy because they are in their original SI unit. So that's the mass. Now calculate the momentum. The first thing you must do, P equal to mv, where m it is the mass of an object, which is 2 kg, multiplied by 1.5. Now you get what, 3 kg meters per second, and you must do what, you must consider the direction, which is to the right, since the velocity of an object is moving to the right. So it is very important for you to consider the direction of an object, or the velocity of an object. We get the direction of an object through its velocity, or the direction of the object's velocity. So the first thing you must do, collect your data and consider the direction of the velocity. Okay, let us do the second one. We have our object of 4 kg, which is the mass, and the direction of motion, or the velocity, is to the left by 0.3 meters per second. Now calculate the momentum of the ball, or the momentum of the object. Remember, the first thing you do, what, you collect the data. So velocity, it is of, since the direction it is to the left, that arrow depicts what direction, so it is negative 0.3 meters per second. Now our mass, it is of m equal to 4 kg. We are happy because they are in their original SI units. The first thing, P equal to mv. Mass is 4 kg multiplied by negative 0.3 meters per second. Get your answer is negative 1.2 kg meters per second, but you must not write it in that way. So just write it in this way, 1.2 kg meters per second. Now the direction is to the left, and you got negative. Negative tells us about left. What is this? Left. So this is how you are supposed to write your final answer. If it is negative, just write that answer in a positive way, then you say left, or down if the object was going down. Okay, here's your ball. It is projected upward, or thrown upward by 2 meters per second up. Now you collect your data. The velocity, it is 2 meters per second, which means it is positive 2 meters per second. So positive tells us, up tells us about positive. Remember the Cartesian plane. Now the mass, it is of 5 kg. We are happy. They are in their SI units. Calculate the momentum of the ball. Therefore, P equal to mv, where m is the mass, which is 5. Don't forget to put the brackets for substitution. Now 2. Now we have what? Our momentum, which is 10 kg, or kilogram meters per second. Now the direction of the velocity, the direction of an object, it was up. Therefore, P equal to 10 kg meters per second. Since the velocity is up, we write up, or north. Okay, so here you are given 3 kg object going, or the direction of motion goes down by 1.5 meters. It tells us that it is negative. Let us say calculate the momentum of the ball of an object. So do it on your own and send your answer, write your answer on the comment platform. to see if you guys really understood what I was doing there. Now we have the delta, that small triangle. Remember from natures of roots, the delta. So in physical sciences, it tells us about the change. What does that mean? The final and the initial of an object. For an example, we have delta A. It tells us that there is what? The change, which is A final minus A initial. So the delta tells us about the final minus initial. So that's what we're going to talk about now, because it is possible, or yes, it is possible for our momentum to have, the object to have its final momentum and the initial momentum. So we're going to use that delta a lot. So remember, delta here doesn't tell us about b squared minus 4ac. No, that's mathematics, nature of roots. But now here in physical sciences, it tells us about the change. Remember, we have delta t. In other words, if we were to explain that, it is t final minus t initial. I don't know if you get it. A delta v, which is final velocity, and the initial velocity. So that's very important for you to know and understand. Alright, now we have something known as the change in momentum. The change in momentum. Yes, change in momentum. The change, it is depicted by what? By the delta. Remember that. And p, which is momentum, which means it is delta p equal to, remember we did something like delta a, it is a final, right? And a initial. Even here, this is delta p, which means it is p final minus p initial. And we know the formula for p, which is mv. So it will be mv final, mv final, because it's pf minus mv initial. In mathematics, your teacher taught you about something known as the common factor, which is m and m. So there is a common factor here. There's something that is similar on the left hand side and something that is similar on the right hand side, which is the m. So we take it as a common factor. Now we'll be left with v minus vi inside the brackets. So this is the formula to calculate what? The delta p, or change in momentum. You can use that formula to calculate the change in momentum. So this thing of change in momentum, actually, for an example, let me say you have a shop where you are selling bread, and the bakery is not there yet. Now you have a queue of people who want to buy bread. Listen to this carefully. Now, as they waited there, you are trying to call the bakery car. So the car, let me say, is of mass 50 kg, and as it is traveling slow, it is traveling at the velocity, or the speed of 60 kilometers per hour. It is slow, and now you are in a hurry because you have a queue wanting to buy bread. Now, as mind you that the car is of 50 kg and it is traveling at a speed of 60 kilometers per hour. Now you try to call the bakery car, or the person who's driving the car, to tell him to hurry. Now he increases his speed from 60 kilometers per hour to 80 kilometers per hour. It means that the momentum before you called or told the driver to hurry, it won't be the same as the momentum after you told him to hurry, because he increased the speed to 80 kilometers per hour. Therefore, now there will be the change in momentum, or the velocity or the speed of the car changed. It was it was traveling at 60 kilometers per hour, but after you talk to him or talk to her, the speed changed to 80 kilometers per hour. That is why we say that there will be a change in momentum. Mind you, the mass of the car didn't change, it was still 50 kg, but the thing that changed, it is what? It is the velocity or the speed of the car. I do not know if you understand that. So when you calculate what the change in momentum, we will use we will say change in P. Now we use the data of the final data. It will be that of the 80 kilometers per hour after I talked to him, because that is when he increased the speed. It means that the 80 kilometers per hour, it is V final, and the V initial was 60 kilometers per hour. Since I haven't talked to him yet, I don't know if you understand that, but we'll do an example so that you can understand what I am trying to say. So the driver was traveling at 60 kilometers per hour before you called him, and the car is of 50 kg. But after you called him, he increased the speed to 80 kilometers per hour. So the momentum before won't be the same as the momentum after. So the momentum after subtracted the momentum before. That's change in momentum. I don't know if you understand that, but it is very important for you to understand. You just pause the video and listen to what I was saying. You'll understand it. You'll understand it. So changing momentum, changing P equal to PF minus PI, where M it is the mass, VF it is the final velocity, minus mass initial velocity. Therefore, changing P equal to M VF minus VI. So you can use that formula there, the last one, because the mass doesn't change. It was 50 before and even after you talk to the bakery guy or the delivery lady. It was still 50, but the only thing that changed, it was what? It was the velocity. And the most important thing before I forget, I am old. I am old enough to forget. It is easy for me to forget. Okay, but if you are given the velocity measured, let me say, as we're talking about 60 kilometers per hour. Now, if you are given kilometers per hour, you know that velocity is measured in meters per second. You need to divide kilometers per hour by 3.6 in order for you to get meters per second. Do not forget that. But if you are given grams, you know that mass, it is measured in kilograms. You need to multiply by 10 to the power negative 3 to get kg. So if you are given kilometers per hour, let me say 60 kilometers per hour, divide it by 3.6. Now if you are given gram, multiply by 10 to the power negative 3. So we have the bakery cars here. So don't mind those cars. I know how to draw. The problem is that I was in a hurry when I was drawing these ones. So don't mind them. Don't mind them. So these cars here, they are not normal, because I was in a hurry. If I gave myself time, I would draw a proper and beautiful car. Okay, now they say calculate the change in momentum. Remember, the change, it is delta, then momentum, it is P. Change in P, or delta P. Now, the first thing we do, write the formula mv minus Vf minus Vi. We need to take what? The data, so it will be easy for us to calculate. Now the mass is of 50 kg. Okay, mass equal to 50 kg. So this mass is still the same thing. So 50 kg there, and on that right hand side is 50 kg. Now the initial velocity it is 60 kilometers per hour, and we have kilometers per hour. Since we know that velocity is measured in meters per second, we divide by 3.6. Now the Vf, or final velocity, it is of 80 kilometers per hour, and we know that velocity is not measured in kilometers per hour but in meters per second. Therefore divide by 3.6. Remember the direction, it is to the right. It means that it is positive. It means that it is positive. Now our mass is of 50. Now the Vf and the Vi, the answer that you will get when you divide it, Vi will be 67 meters per second to the right. Remember that Vf equal to 2.22 meters per second. Consider the direction, so it is positive, and here it is also positive. Why? Because the velocity goes to the right or to the east. So m it is 50, Vf it is 2.22 minus the velocity the initial velocity, which is 16.67. Now use your calculator here. You get change in P, or delta P, or change in momentum, equal to use your calculator to get 277.5. So delta P is kg meters per second. Consider the direction. Since it is going to the right, you say right or east. So that's very important. The first thing, you are given the object and its its initial velocity, which is before, and the final velocity, which is after. Initial before, final after. So collect your data, make sure you substitute correct SI units. Note that if the momentum of an object changes by 10 kilogram meters per second, it means that 10 kg meters per second, it is the change in P, because it changed by. Now if the momentum of an object changes to 10 kg meters per second, it means that 10 kg meters per second, it is what? It is the PF, final momentum, or it is the final velocity of an object. So you check changes by, or it is the change in P. Now changes to, it is the PF, or it is the final velocity. So make sure that you know that this is very important. Changes by, then we say an object changes by 2 kilometers per second, 2 kg meters per second. It means that it is what? It is changing P, or it is the change in momentum. For an example here, you are given these two cars. A car of 60 kg moves to the right at 15 meters per second. Then a braking force is exerted or applied on the car. The velocity of the car decreases to, or changes to, 10 meters per second, which means that 10 meters per second is what? This PF, or this final velocity. Then they say calculate the change in P. But if they say it changed by 10, it will be the change in P. Alright, so you collect your data. Now the mass, or initial velocity, final velocity, and so before you can perform your calculation, make sure that you take your data. So the velocity is of 60 kg. So that 60 kgs of a car 1 and car B, that's the same car. Now it moves to the radius speed of 15 meters per second. So this is the initial one, initial velocity. Then they say that okay, it moves at 15 meters per second. The braking force is exerted on the car. The velocity of the car decreases or changes to, remember, 10 meters per second. In other words, it is what? It is V initial. Remember, changes, V final changes by, it means that, okay, for example, changes by 10 kg meters per second. That will be our what? That will be our change in P. But if it changes or decreases to maybe changes to, we're talking about what about the PF. If it changes to 10 kg meters per second, we're talking about the final velocity or the final momentum. So the velocity of the car decreases to, we see these two here, or decreases to 10 meters per second. In other words, it tells us that that 10, it is what? It is the final velocity. Then you calculate your what? Your change in P. So here it is 10, not 8. So okay, for the first thing, take your data, collect it. Now change in P equal to M, open bracket, Vf minus Vi equal to, now our mass of 60 kg. Remember, the mass doesn't change, only the velocity. It is the velocity that changes. So 10 minus, remember the direction is to the right, minus 15 meters per second. Therefore here we have our answer as negative 200 kg meters per second, but we must not write the negative, so write it as positive 300 kg meters per second. Since the velocity was going to the right, it means that it will be left. I don't know if you get the change in P equal to 300 kg meters per second left. The most important thing, collect your data. Make sure you understand what's written on the statement. You understand your statement, collect your data, then substitute using correct SI units, and do not forget to consider the direction, because momentum is a vector. So a vector, you must see what the direction and the magnitude or the size of an object. So the size is 60 kg and the direction is to the right by 15 meters per second. Don't know if you understand this. Alright, a soccer ball with a mass of 100 grams rolls towards the goalkeeper at a velocity of 4 meters per second. He kicks back at a velocity of 2.5 meters per second. Calculate the change in momentum. Collect your data. Since you see the mass is in grams, which means you convert it to kg by multiplying by 10 to the power negative 3. Now the initial velocity there, you just discover which is the initial velocity and which is the final velocity, and you calculate the change in momentum, then leave your answer on the comment platform. Then we'll tell you if you are correct or incorrect. But I know that you guys are getting the gist of what we are doing here. Do not forget to leave your answer on the comments platform. We have something known as the conservation of momentum, MV, which is mass multiplied by velocity. That's momentum. So momentum can be conserved. So the word conservation comes from the word conserved, which means no change. So momentum can be conserved only in an isolated system. So conservation comes from the word conserve, which means there's no change on that object, because we get the momentum of an object from the object. Yeah. So that's very important for you to know. Now, this term you must understand it, which is isolated system, or you must know it, a system of zero net force. Now, the principle of conservation of linear momentum, you must know its definition too. So the total linear momentum in an isolated system remains constant. So the word total there is when we sum the initial momentum with the final momentum. So the total linear momentum in an isolated system remains constant. Its formula is total P initial equal to total P final, where P it is the delta, not delta but sigma P initial equal to sigma P final. Alright, I want to explain the issue of the total P initial, which is the formula for the conservation of linear momentum, equal to total P final or total P after. So the total, actually get the total when we add two values. The answer, it becomes a total, and we were taught number pattern or in sigma notation that this is sigma. It tells us about what the addition. Alright, so sigma P initial, so total P initial is still the same thing as sigma P initial equal to sigma P final or sigma P after. That's still correct. So sigma P initial, it means that a P initial of 1 plus P initial of 2 equal to P final of 1 plus P final of 2. And you know the formula for P. So it is MV. Therefore, P initial of 1 will get what? The M1 velocity and initial of 1 plus M2 velocity of and initial of 2 equal to M1 and the velocity and final of 1 plus M2 V final of 2. So this is the formula for the conservation and for the principle of conservation of linear momentum. So this thing, it is mesh 1 and here it is mesh 1. Then we have mesh 2 and we have M2 there, which is mesh 1. So the 1 tells us about object 1, and the 2 tells us about object 2, which means that in the principle of conservation of linear momentum, here we're talking about two objects. So it results, the principle of conservation of linear momentum results into we're talking about two objects. I don't know if you guys understand that. So for the conservation of linear momentum to result or to exist, there must be two objects interacting or two objects colliding. So it is very important for you to understand that when I have two objects colliding or interacting, it means that the principle of conservation of linear momentum takes place, or the principle of conservation of linear momentum exists. So sometimes they say the principle of conservation of linear momentum, or they just say conservation of momentum. Is still the same thing. So it is very important for you to know the formula and the definition. So we have something known as a collision. Actually, a collision results when objects interact. So that's the definition of a collision: the interaction between objects. Interaction between the objects. So when they interact, collision or yes, collision results or collision takes place. All the time when objects interact or two objects interact, the principle of conservation of linear momentum takes place or it results. Now, the interaction between objects or the collision. So these are examples of collision. We have object 1 and object 2. As I say that the principle of conservation of linear momentum takes place when two objects interact. So since this is going to the right and this is going to the left, so they will collide. Then the principle of conservation of linear momentum exists. Now here we have object 1, which is the bus. It is not a good one because I was hurrying. I'm good at drawing. So when they interact and on that zigzag line that I drew there, so they collided. Now here we have object 1 and the trolley at rest. So they throw that object inside the trolley. So when the object get inside the trolley, or when it gets inside the trolley, it interact or it collides. So don't worry about the last one here. As I told that sometimes my age is way too far. Sometimes I just write things which are not necessary. Elderly people, they are likely to forget, or it's easy for them to forget. Yeah, but the most important thing for you guys to know is that the principle of conservation of linear momentum results or takes place when two objects interact. So here I was showing you the examples or scenarios of objects interacting or colliding with one another. Yes. Principle of conservation of linear momentum cannot result if there's one object, but it results when there are two objects colliding. Alright, there are three formulas derived from sigma p initial equal to sigma p final. So whenever you are asked to calculate whatever, maybe the mass or the velocity, you write this formula first before writing another thing. Sigma p initial equal to sigma p final, or sigma p before equal to sigma p after. Now the first, you use this formula if objects moved separate initially or before and after the collision. So the objects move separate before and after the collision. For example, the snooker balls or the pool balls. So when you hit the balls that are pegged by that white ball, that ball, it was moving separate, and after it hits or collides with those other ones, it moves separate. Now use this formula to calculate mass or velocity if objects moved together after the collision. So objects moving together after the collision. For an example, as I made that example of throwing an object inside a trolley. So when I throw it inside the trolley, so they will move together. So you can use this formula. So all the time, make sure that you check the scenarios. Make sure that you check the scenarios to understand if I am choosing this first example or the second example. So you'll be asked to calculate velocity or mass. So make sure that you understand your scenarios. So the third one, you use it if objects moved together before the collision. If you can check these two cars, they are pulling each other, they are moving to the right. So they're moving together before the collision. Now, let me just show you the collision part here. Now, if this rope tears apart, that's a collision, and they will move separate after the collision. But before the collision, they moved together. So that is when you are using this formula to calculate whether velocity, but it is usually asked to calculate the initial velocity. So make sure that you understand the scenario. So before you can write anything, make sure that you write that first thing there before choosing from the three formulas. So it is very important for you guys to understand your scenarios. Now we will do examples which require these three formulas and see how you tackle questions using them. Suppose you are given a 2 kg with a mass of 5 meters per second to the right and 4 kg with a mass of 2 meters per second to the left. So this is initial and that's final. Now you see those two two balls, 2 kg and the 4 kg. They are not in contact, they are moving separate. Now after they've collided, so the 2 kg and the 4 kg collides on that zigzag line there. So the 2 kg is going to the left after it has interacted with the 4 kg block. Now you can see that they move separate before and after they are moving what separate, which means I must use the first equation from the three equations that I wrote for you there, guys. Now they say calculate the velocity of the 4 kg block after the collision. The first thing you must do, you must collect your data for a 2 kg ball, not block, ball, and mass 1 which is 2 kg, and velocity initial of 1 equal to 5 meters per second. So since the ball is moving to the right, or the motion of an object moves to the right with the velocity, it means that 5 is positive. Therefore the other mass, which is m1, no, it's not m1, it's m2, which is the 4 kg ball or object. Now vi2 equal to negative 2 meters per second. Why? Because it is moving to the left, so take direction into consideration. Now our final data, mass 1, it's still that 2 kg there. Now v final of 1, it is negative 3 meters per second, since it's going to the opposite direction, or it's going to the left. Then m2, it's still the 4 kg ball. Then vf2, we don't have it, so it is the one that we are going to calculate. So calculate the velocity of the 4 kg block after the the 4 kg block after the collision. The first thing, you see these blocks, they were moving separate before and after. This one will go to the left and that one it will certainly go to the right. So the first thing, before choosing your formulas from those three, this thing is important. Not change, but sigma p initial equal to sigma p final. Therefore you choose your first formula. Why? Because they move separate before and after. Now vm1 vf1 plus m2 vf2. Then when you are here, it's easy because you already collected your data. Just substitute m1, it is 2 kg, v initial of 1, it is 5 meters per second, plus mass 2, which is the 4 kg. vi2, it is negative 2 meters per second, equal to mass 1, which is 2 kg. vf1, we have that negative 3 plus mass 2, which is the 4 kg ball, and we don't have v2. It means we are looking for v2. So make sure that you collect your data, because it makes things easier. Use your calculator, you will get 2 equal to Then on the right hand side you get negative 6 plus 4 VF2. Then you transpose the 6, so it will sum 8 to get, you will get 8 equal to 4 VF2. Then you divide both sides by 4. Then your answer, it will be 2 meters per second equal to VF2. Now we must take the direction. So as that will go to the left, as that is going to the right, the left, the 2 kg means the 4 kg will go to the right. So it is very important. The first thing, understand your statement or understand the scenario. If the objects are moving separate before and after, it means that you choose the first formula. Alright. We have 1 kg ball and the 3 kg ball. They are moving at 1.6 meters per second. So initially they are moving together. Then after the collision, they separate. So the first thing that you must do, make sure that you collect your data and understand your scenario. Calculate the velocity of a 3 kg object after the collision. So you collect your data, and for initial you have 1 kg, which is mass 1, 1 kg. Yeah, then V initial, it's that 1.6 meters per second. So V initial of 1 is 1.6 meters per second. So make sure you understand your statement, or before that just collect your data. Now the 3 kg block, it is of mass 1, which is 3 kg. I mean it's mass 2, not mass 1. Then VI2 equal to it's equal to 1.6 meters per second. Then the final data, we have mass 1, which is 1 kg, and VF1 equal to negative 1.1 or negative 1 meters per second. Then VF, since it goes to the right, it will be positive, but we don't have it. So it is very important for you guys to collect your data, calculate the velocity of a 3 kg block after the collision. Before you can choose your formula, just it is very important to write sigma p initial equal to sigma p final. Then you can see that the objects, they move together before the collision and after they move separate. So we use this one, m1 plus m2 v initial equal to m1 vf1 plus m2 vf2. Why? Because the objects move as a unit before the collision. Then m1 we have 1 kg and m2 have 3 kg. Therefore we have 1 plus 3 vf v initial, it is 1.6, positive 1.6. Why? Because they are moving to the right. Now mass 1 is still that same mass, which is 1 kg. VF1, which is negative 1 meters per second, plus M2, which is the 3 kg VF2. So that VF2 is what we are looking for, final velocity of 2. 6.4 equal to, use your calculator, get negative 1 plus 3 VF2. Then you transpose the 1 you will get 7.4 equal to 3VF2. Now you divide both sides by 3, divide by 3. Okay, now you get your answer as 2.47 meters per second. Why? Because we're calculating velocity, VF2. So these ones, they will cancel. So it is very important for you to consider direction. So it will go to the right after the collision. So it is very important. Make sure that you understand your statement. So the objects, they move together before the collision and separated after. That is why I used M1 plus M2 VI initial equal to M1 VF1 plus M2 VF2. So the most important thing is that you must understand your statement or the scenario which you might be given. Collect your data, then choose the correct formula. So do this activity, then leave your answer on the comment platform. Just want to check if you guys understood what I was doing. So calculate the speed of the block bullet system immediately after the collision. So you must discover which formula from those 3 formulas, which formula to use. But the first thing, don't forget that before calculation, you must write the formula. Okay, we have kinetic energy, which is the energy an object has due to its motion. So kinetic energy can be conserved or not conserved. So the formula for kinetic energy is EK equal to half mv squared, where m is the mass in kg and v, it is the velocity in meters per second. So we're going to talk about it a lot. Now, as we talked about collision, we say that collision is the interaction between objects. So we have 2 types of collisions, elastic and inelastic. So when we define elastic collision, it's a collision in which kinetic energy is conserved, or collision in which EK is conserved. And the inelastic collision, it's a collision, actually it's the opposite of elastic, collision in which EK, which is kinetic energy, is not conserved. So we must know how to differentiate the 2 collisions. So here EK is not conserved, and there EK is conserved, which is elastic. So you must know how to define elastic collision and inelastic collision. So it is very important for you guys to know how to define or differentiate between the 2. Yeah, we are continuing as we're talking about the collisions. Yeah. Now, there's another thing which you must know, guys, that there are 2 ways to prove if a collision is elastic or inelastic. The first one, inwards or by performing a calculation. So you must know both the ways. So now if you are explaining inwards, if a collision is elastic, you say that there was no loss in EK due to objects moving separate after the collision. For an example, snooker balls, when you hit those balls, they move separate after and before the collision. Therefore, we'll say the collision is elastic. If the collision is inelastic, you say that there was a loss in EK due to objects moving as a unit after the collision. So it is very important to know this. that if a collision is inelastic, it means that there is a loss in EK due to objects moving as a unit after the collision. But if it is elastic, they move separate after the collision. Okay. Now, by performing a calculation, or before that, I forgot something. There's a formula for elastic collision and inelastic collision. So the formula for elastic collision, since you know that it is sigma EK initial equal to sigma EK final, and the formula for inelastic collision is sigma EK initial. Oh, sorry, here I supposed to write final, since on the left I said initial. Yeah. So sigma EK initial is not equal to sigma EK final, since the definition says that kinetic energy is not conserved, so that's what it means. So by performing a calculation to prove if a collision is elastic, the first thing that you must do, you calculate sigma EK before. You say sigma EK before. If you are given a scenario, calculate the sigma EK before, which is half EK before, you know the formula, which is 1 over 2 M1 VI1 squared plus M plus half M2 VI2 squared. Sorry, I wrote VF2, it's VI2. So you get your answer, then you put joule because it is energy measured in joules. Now, again, you do it, you calculate sigma EK after. Pay attention, which is half M1 VF1 squared plus half M2 VF2 squared. Now you get your answer, you put correct SI unit, which is joules. Now after you've done that, if you get 20 here and here you get 20, it means that the collision is elastic. But if you get 20 here and here you get 10, it means that the collision is inelastic, because the kinetic energy before and the kinetic energy after is not common. Don't know if you understand that. But let me write this. If you got common answer when you calculated EK before and EK after, it means that the collision is elastic. Therefore, you will say, before saying elastic, you say sigma EK before equal to sigma EK after. Then that is when you will say, therefore the collision is elastic. You see that? But if you get different answers, or answers which are not common, before concluding saying it is inelastic, you must write the formula for inelastic. Then you say the collision is inelastic. So first thing, you write sigma EK before is not sigma EK after. Therefore, you conclude then saying that the collision is inelastic, or inelastic collision. I don't know if you understand that. So if you have common answers, EK before and EK after, it means that the collision is elastic. But the first thing you write the formula, even if they are not common, you write the formula first. Now, by calculation, it's very important that when you have common answers, EK before and EK after elastic collision, but write the formula first, which is sigma EK before equals sigma EK after. And if the answers are not common, you write sigma EK before is not equal to sigma EK after. Therefore, you conclude saying that the collision is inelastic. Okay. So this will be the last part here, and I will continue, guys, with impulse. I will continue with impulse on the next video, which will be momentum. So I'm separating them here. We're doing momentum only. Then next we will, or the next video which I will upload soon, I will do momentum separate. So make sure that you subscribe, you share the video, you like, and you comment. All right, so thank you, guys.